All right, everyone. So welcome to today's workshop. It feels a bit like class, doesn't it? You know, we have like a lesson, we're going to go over something, then there's going to be a lab, and then we're going to talk about it. So it's basically like that, just, ongoing, things like that. So I have to admit I actually kind of respect the people who actually showed up to do this because, I got lots of responses afterwards from lots of people. Oh, I love it, things like that. That sounds so good. Count me in. But of course, right, 100 people say they'll do it, and then 4 show up. So I tip my hat to you all. So thank you for making it. All right. But in any event, let's kind of go ahead. So do we have, real quickly here, I'm going to start sharing my screen. If that's okay with you, everyone, if I have your permission. All right. You don't really need to see my face for all that much. Let's take a look. Okay, everyone. Can we see my notebook?
Yes.
Yes.
Yes. All right. Beautiful. All right. Okay. All right. So this is kind of recap here just to start, right? So import pandas and profit, which are really going to need for today's class, and then read in the web page hits. For the uninformed, just remember this is basically just a log of web page hits on Peyton Manning's Wikipedia page from about 2007 to 2014. All right, so that's what we're seeing. And so it is a monotonically increasing time series. And let's just make sure. So we have this?
Yeah.
Yeah.
Okay. All right, beautiful. All right. I was thinking, we might have new people here, but we don't. We just have everyone that showed up 2 weeks ago, minus a few. But just to sort of recap, since we're not doing this every Tuesday, Thursday, or what have you, we'll go over a little bit of review here. All right. So previously, right, essentially, we just gave ourselves an introduction to profit, which is used for forecasting. And so it doesn't really do anything that other libraries couldn't potentially do with a lot more jerry rigging, but is a very convenient way to get automated forecasts that are already pretty well fit to your data. And then it handles a lot of some of the nuisances you typically have to deal with if you have time series data. All right, so we worked through some of the basics and then essentially, right, fit our model on COVID-19 data, did some cross-validation, and then got some predictions going forward. We'll go through here just a few of the smaller points for how it worked, just to make sure our memory is jogged. Okay, but before we do that, I'll talk about this slide because apparently I forgot that I put it here. All right, so right, a couple of weeks ago, going through the basics, syntax, how it works, and then basically build a fairly decent out-of-the-box forecasting model. What we're going to talk about today, working with Changepoints. So if you have specific breaks within your data, where things radically change, this can be especially useful if it happened recently. Again, it was actually one of the motivations for giving this particular workshop on this particular topic, because I was giving some workshops and then people were mentioning to me that they're having to make predictions on things, and COVID recently happened. So how do they account for the fact that in the last 3 months they had this big discontinuity, and that kind of caused other patterns to maybe not be as valid as they were before? All right, so we're going to talk about how to deal with those things specifically, and then also how to quantify the impact they may have had on some sort of result that you're looking for. All right, and we'll also talk about if you want to go in and account for special events or holidays and capture either lags either before or after the event occurred, you have pretty good options for looking at these things fairly analytically in profit. So that's what we're going to do today. All right, we're going to keep on looking at the web page hits, all right, and see how popular Peyton Manning was on one day or the other. And then the lab is going to go into the COVID-19 data, and we'll look at things like Memorial Day, 4th of July, and then the George Floyd protests, and then see, if actually including them actually adds any sort of quantifiable impact to the accuracy of our model, and then sort of think about what the additive impact those events may or may not have had on sort of total COVID-19 cases. All right, and that's what the class is going to wrap up. So before I begin, right, any questions? We're going to do a little bit of review from 2 weeks ago, okay, because just in case it's a bit rusty. But before I do that, anything that was maybe not clear from the last workshop?
I'm good.
And Edwin is good. All right, Rashad.
All
All right. All right, is Shella good? Shella is good. All right, and then is Ricardo, are you good?
Yeah, I'm good.
Okay, so everyone's good. All right, so if you're all good, then I'm good. All right, so let's go ahead, everyone. Oh, all right, let's go ahead here. I thought someone came in. I got excited, but it's okay. All right. All right, so okay, all right, so a little recap here, all right, just to kind of warm ourselves up a little bit. Okay. All right, we have this right over here, right? We imported Profit, we imported Panda, so I'm gonna guess we're okay there. All right, so we're already here from what I can tell. All right, if you were not here, right, you didn't say so, so there's another chance, right? But my assumption, we had about 15 minutes to get this ready. All right, so we have DF. All right, I would start following along here just to make sure we're okay, right? So Profit basically follows the scikit-learn API, right? It's designed to do that deliberately. It also works with pandas first and foremost. So just like everything else, you initialize it like you would at scikit-learn, and then you call fit on your data frame. If we want to sort of recall from what we looked over previously, the data frame has to have columns that are labeled DS and Y. That's just what it's designed to look for. So you have to rename things appropriately if you're not there. All right, so you fit. All right, and then to make a prediction, all you really need here, all right, is you just need a pandas data frame with a date column. Okay. There are a few different ways you could do this, right? But Profit is designed, right, to take pandas as input, okay? And it has to be a data frame, not a series. I'm not sure if we call the differences between series and data frames, right? Series is just the individual column, but then data frame is something for multi-column labels. It's kind of a small detail. All right, but notice right over here when I'm making the prediction, DF, I am putting both the brackets around DS, if we can see that.
Yes.
Okay, that's just turning it into a proper data frame. So if you want to take a look for yourself, if you remove one of the brackets, it would go from being a data frame to a series. Just as a quick. So if we do this, DF, DS, right, that is a series. Okay, if we had both brackets around it, it turns it into a data frame. Normally, data frames are useful if you have more than one column, all right? But in our case, we just need the one column right over here, right? So what that means, all right, if you have a data frame with a date column, one can go ahead and make predictions. There were a few questions about this the last class that we had, all right? But essentially, it spits out all sorts of numbers for you, all right? But the basics of what it does is it looks for a general trend within your data, and then it looks for the different time decompositions, right? So annual, weekly, monthly, you know, quarterly patterns, so on and so forth. And then essentially all it does is it basically just adds them together, all right? So when we call predict right over here, let's take a look. Do we have this on our screens? Mod, predict, DF, and we give this stuff right over here. Just make sure we're good with that.
Yep.
Yeah.
Okay. Yeah, I decided not to live code this one just due to time. It's actually a lot easier for me to make slides beforehand. So it saves me about 90 minutes of prep. So I'm just gonna go with the slides for now. All right, so we have all this stuff. And then basically, all right, you have your different components here, but essentially all it's doing is taking the trend and then the different time-based components, and then it just adds them together. Some of the syntax we used from the previous class, this is just a convenience function, make future data frame, periods 30. All it does is it just takes whatever data set that you fit your model on and just adds this many time increments to the very, very end, right over here, all right? So it doesn't really do anything fancy, all right? Like if you took this data set right over here and then literally just added 30 sequential days to the end, that's really all it's doing right over here. So it's not magic or things along those lines. You could probably write a function that does the same thing in less than 10 lines of code. You know, so don't think of it as being anything especially special. It's just a convenience function built in. All right. And so pretty much when we went ahead and made our predictions, right, we were going ahead, we were predicting on this future data frame, which is just the original time series with 30 additional days added in. And then predictions right over here, right, was just that elaborate data frame of different time series predictions with a whole bunch of values added in. Okay, with about the 1 to 2 dozen different time-based components that Prophet will go ahead and break down and analyze for you. All right, so to move ahead here, all right, so how it makes its predictions, again, the default is to be an additive model, which essentially what it means is at every single particular time point, it essentially just adds a weight to every single time value and takes their linear combination. So the fitting procedure that Prophet uses is a little different than traditional linear regression, but how it actually combines the different values to add them up together to get the final output is essentially just taking the weighted values of different types of the time decomponents and then just sort of multiplying them by some sort of weight and then adding them together later on. So it is actually not too different from linear regression, but just fit using a Bayesian way here. And then if we wanted to, right, you could take your predictions data frame. This is the one with the values y hat upper, y hat lower, things along those lines. All right. And then over here, just broken down into their different components. So in this case, right, we can see here, there's the general overall trend, right, for what sort of happened with Peyton Manning's data. And then there is the weekly and then the yearly pattern. If your data happens in increments that are smaller than 1 day, it can fit things hour to hour. But in this case, it didn't do that, okay? So we have these 3 different time components right over here, all right? And then finally, what we do then, all right, if you take a look at the predictions data frame and then look at these 3 different column values right over here, trend, weekly, and yearly, okay? Let's make sure we're here. If I can just get some sort of thumbs up that we're good. I don't want to leave anyone behind. Okay, Rashab is good.
Yeah.
Yeah.
Beautiful. All right, beautiful. Okay, all right. So if you just grab these 3 different columns right over here, trend, weekly, yearly, okay, and then you sum their rows, right? If you remember axis 1 versus axis 0 in NumPy and Pandas.
Yep.
Right, okay, so Shelley remembers. For everyone else, just to make sure, if we say sum axis 1, that means take these values and then add them up across the rows, right? So we're just adding the trend and then the weekly and then yearly components for every single time point. And then here we go. Okay, and that's all our predictions are. Okay, so if you were to take a look at predictions y hat, okay, this is basically what y hat is right over here. It's just adding these things together. All right, let's see any questions people have so far. Okay, one thing I'm going to point out here, all right, which is actually I think a bit interesting. Ankit is actually not here today, although he showed up late last time, so you know maybe he'll be here before too long. He asked about getting confidence intervals for your predictions. All right, and so I didn't have a great answer for him because the thing I need to make use of, I didn't quite have it committed to memory how it worked. Let me go ahead and fit this thing. We'll let it do its work. All right, and then we'll do this. All right, so predictions. Periods equal to 30 right here, so beautiful. And then, oh, it's actually make future data frame, not predict, excuse me. You don't predict the future data frame, we're gonna make it. All right, okay. All right, so we'll do this, prids, mod predict. My working assumption is you've already typed these things in for yourself. So you're just waiting on me to go ahead and get caught up. Okay, all right. So one thing that came up that was a bit interesting from last class, I thought it would be worth discussing it over here. So take a look. I still don't quite remember what it is, but if we'll do this, hit tab. And pretty sure I'm going to take one crack at this. Okay, predictive samples right over here. And if we do this, if you wanted to get a really granular way, all right, sort of how Prophet assigns confidence intervals, all right, this would allow you to assign probability intervals at almost any level of granularity. Let's take a look. We're probably going to wrap up this sequence with more of a deep dive into how Prophet actually works and how it generates its predictions. It actually uses Bayesian modeling, which is something a little bit different than what we've discussed so far. All right, so it's actually, the way it actually works underneath the hood is not entirely similar to things we've talked about beforehand. All right, so it'd actually be worthwhile. But for any event, essentially what it does is it generates lots of data based off of fitted probability distributions. Let's take a look over here. Do we have this mod.predictive samples with prids passed in?
Yep.
Okay,
Yep.
all right. So let's grab, you notice here, this is just a dictionary, right? So let's grab the y-hat key. All righty, and let's just save this. All right, so we'll call it probs. Seems good. All right, notice here, this is just a NumPy array. All right. So we'll save this. And if we take a look at here, probs. All right, now notice over here, right? So it's 2,935 rows and then 1,000 different columns. Ready? Our data set. Or rather, our future data frame. Right, notice here it's also 2,935 rows. All right, so basically what this means is, if we were to look right at the first row of this NumPy array, we would have, right, 1,000 different samples. All right, and so these are basically the generated predictions from Prophet for the first time step. Is everyone with me there? All right.
Yep.
So essentially, when we are getting our predictions, y hat, or it says the upper or the lower confidence interval, it's essentially just grabbing the 50th percentile value for y hat. And then, you know, for things like y hat upper or y hat lower, it's just getting things at the 0.025 or 0.975 percentile. And that's where these values are coming from. So when Prophet is actually generating its predictions, what it's first doing is generating probabilistic data based off of implied probability distributions. And then for every single time step, you have 1,000 such simulations. And then it's just sort of taking, you know, the middle or the top or the bottom of those values to assign the confidence intervals. All right. So do we have a basic grokking of what we're seeing here and what it tells us?
Yep.
Okay, beautiful. I like hearing that, Shella. So said so casual, right? Yep, I got it. I'm good.
I actually have a quick question.
Yeah, sure.
So then what is the default confidence interval that Prophet works with? So the y hat and the y...
Y hat is basically the 50th percentile of these numbers.
And the y upper and lower are...
0.025 and 0.975.
Oh, okay, brilliant. You just said that.
It just takes these numbers right over here, and then,
Right.
it just finds the whatever percentile it is and things along those lines. But if you wanted the middle 50%, right, or the 99th percent or things along those lines, it would just be taking the percentile value of these things.
Yeah.
Okay. And then there are any number of methods to find percentiles inside NumPy or Pandas, you know, so you could kind of do it however you wanted. I'm pretty sure there's something here called percentile for NumPy, if I'm not mistaken. I'll see here if I can tab it here. I'm pretty sure there's something called NP percentile. You could turn this into a data frame if you wanted, you know, and there's a percentile method in pandas, whatever, right? I mean, you could figure your way around that. All right, so let's go ahead here. Yeah, okay, here we go over here. And so we take a look, I'm pretty sure, let's just make sure A, Q, axis 0. All right, A, array like a float, axis out, ND array. I'm just going to assume, yeah, here we go. All right, so essentially here, right, if we did this, NPI percentile, right, this would just be whatever the data we're taking in. And then if we wanted the 50th percentile right over here, we would get that. Okay, and then if you wanted the middle 50%, right, you could just do this. Right, and so on and so forth. But looking at these two things, right, so that would be the middle, like sort of the inner quartile range, right, of the 25th to 75th percentile would be 8.52 and 9.16. And so you could pretty much do whatever you wanted with that, that you'd like. And so when we talk towards the end of this sequence about Bayesian methods and how they generate their predictions, you often hear it referred to as probabilistic programming. Because literally the way you make predictions in the Bayesian way is you generate a whole bunch of synthetic data from implied probability distributions based off of whatever kind of assumption that you're making. And then you just kind of take their average values and things like that. So they make it very easy to get fairly precise probabilistic inference in terms of like what something's true value is. So we'll see that here at a later step. But in any event, right, if you just want to go ahead and get uncertainty intervals for what an answer truly was, profit and anything that uses Bayesian inference in some ways will actually give you slightly more comprehensive answers than other methods. All right, and that is all I have to say about that, everyone. So if we're okay, we'll just go on to the next slide. And the silence is deafening, so I'll just take that as a yes. All right, so let's just kind of move on to the next step. All right. Okay, all right, and then also here, something else we discussed previously, just to make sure we're okay with it, all right, was basically model fitting. All right, we're actually gonna see this in a bit more detail today, how it works, all right? But if you remember previous class, right, when profit out of the box without any sort of parameter tuning, this was the relationship between the observed events and then the predictions we were making. Okay, and then we saw here it captured a general trend, but also was not particularly responsive to any of the short-term breaks. Okay, because we can see here the pattern that we're getting is a little bit crude because we captured this general trend, but at the same time, though, our overall predictions are not responding too much to some of these discrete breakpoints. Okay, which lots of times is good, right? So if you have a time series of that's maybe 5, 10, or 20 or 50 years long, you don't necessarily want to overreact to short-term patterns. But in our case, this was a little maybe not as advantageous simply because COVID is very, very short, right? Our data set is not very thick. And then also, really sort of outbreaks of COVID have been extremely patchy. Right, they kind of are characterized by these very discrete discontinuities, which happen fairly suddenly. All right, so in terms of bias versus variance, we could say this is maybe a bit too much bias and maybe not quite as much variance as we would like. Right, and then we saw here, right, if we wanted to adjust our model a bit more sensitively to the data at hand, we got something like this, where we can see here up until about the last 15 to 20% of the time series, we're actually hugging the curve pretty carefully, okay? And that was changing something called the Changepoint prior scale, okay? And so the way we did that, if you remember, was this, right? That number, it basically goes between 0 and 1. And 0 basically means it's not responsive at all. And then 1 means, you know, it basically just spins itself around every single time there's some sort of breakpoint. Also, just for whatever worth, when we say the prior scale right over here, It is actually using L1 regularization. So if you remember from our data science class, that's when you sort of enforce some sort of constraints where you limit the size of your coefficients to the absolute value of all of your weights, and then it shrinks some of these things to 0. All right, so it's actually doing something fairly similar to lasso regression, except just in a slightly different format. All right, and so it turns out we used cross-validation at the end of the class about 10 days ago, right? And then what we got at the end was a prior scale value of about 0.25 gave us the best cross-validated results because we went through 3 or 4 different versions of that value, and that one gave us the best average MAPE using 4 or 5 different periods within our data set. All right, and that's where we left things off, right, a couple of weeks ago. All right, so if we're nodding our head, I can't see any of you actually in person, but if we're nodding our head to ourselves in our computer, like that all makes sense, right? We're good, Jonathan. Now we can go ahead and then begin today's class.
Yeah, I think
Yeah, all right. Everyone just kind of cool, easy, breezy about it, feeling nice and confident?
Yeah.
Yes, sir.
All right, good, good. All right. All right, so let's go ahead here. So what we're going to talk about today really is how to appropriately modify models to account for special events or special days or particular breakpoints within your data. All right, so again, none of the people who asked me about this have actually showed up to these workshops yet. But there are quite a few people who are taking some of the weekend workshops at GA. And so they're asking about, so we have COVID happen, things like that. So how do we account for COVID and that kind of stuff? And then more generally, if you're doing some form of demand forecasting, and so maybe you have things like special sales, or there are certain holidays, or there's Cyber Monday, or things along those lines, and you want to be able to accommodate for those things, both to make better predictions, but also to get a better feel for how much they contributed to the final outcome. You have pretty good choices for doing these sorts of things inside Profit. All right, so that's what we're going to talk about today. All right, so that being said, first thing we're going to go ahead and discuss here are change points. All right, so we've already sort of been exposed to this a little bit because we had change point prior scale, right? So essentially what this is referring to is probably the most important way Profit actually fits models to data is when it fits the model, it pretty much is always looking for changes within the trend from one moment to next. And when you call fit, it automatically assigns breaks in the trend for you. All right. And so you can actually visualize this relatively well. So what we do we have mod, some variable called mod or whatever represents Profit? If you go ahead and type this in, okay, these are all of the learned breakpoints that Profit provides for you right away. Okay. We're going to talk about some ways you can specify this manually, but when we called fit, okay, Profit just sort of assumed that these were the most natural breaks in trend from previously occurring results. And so it used these to calculate changes in the direction of the data. All right, so remember here, if we go back our different time components like this, all right, so really the reason why these things move in these particular ways is typically because they're influenced by breakpoints throughout the time series itself. All right, you can visualize this easy enough. So we'll take a look here. All right, let's take a look at this code right over here. So if you want to go ahead and then add it in. All right, this is just if you wanted to visualize, all right, the actual breakpoints within your data and then when they were assigned. Okay, this would be a way you could see it if you wanted.
What is the GCA that's in the following the fig?
Oh yeah, GCA right over here. Basically, what it allows you to do is take a single variable and then break it apart into its different components and then overlay it on the same plot. So essentially what it does right over here is all these different values that we have here for the individual change points, like this. Okay, it essentially allows us to do a clean overlay all at once without a lot of additional work.
Okay.
Okay. Good. Other questions?
So I have a question actually.
Sure.
So if you didn't include the GCA, would it change the output or would it just be more like computationally expensive?
No, the figure itself wouldn't render correctly. You have to go ahead and do other lines. You can try it for yourself,
Okay.
but literally the chart itself wouldn't display the same way.
Gotcha.
I haven't literally tried it myself. So, we could try over here, back here. You know what? I'm curious, so we'll take a look at it. You could still recreate the same plot, but it would just take more work. Let's take a look here. 1 minute. All right, let's do this. Predictions. I think I have it called PRIDS. Let's do this. This. Okay. And then, so I guess, right, the key moment here. What happens if we do this right over here? Okay, yeah, and the lines themselves don't show up.
Okay.
Okay, yeah, so it's good essentially here, Shella, if you have a list of sort of attributes of something, right? And you sort of want them to sort of show up at their respective points and they're all kind of combined into a list. Fig.gca just allows those things to sort of show up individually inside the plot. So it's a good way to take, like, if you just have a list of values and you sort of want them just to sort of show up in the right spots, then that's what it does.
Got it.
For whatever it's worth, we have actually seen fig.gca in one other spot. I'm going to test your memory here. I'll be tickled if you remember this, but I know you take very, very good notes, so I know you're paying attention to that, Shella. But if you remember the chart that we used to plot coefficient paths in Ridge and Lasso, where we actually looked at the different values of alpha and we sort of saw how the actual values of the coefficients sort of expanded or shrunk at sort of different levels of the tuning parameter. I can actually post a code snippet in the Slack channel afterwards, but it actually uses fig.gca to do the same thing. So remember lreg.coef or whatever, it's just like, it's a list of the coefficient values. And so to sort of break those apart into the chart separately, we use fig.gca.
Gotcha. Okay.
Okay. So it's just used for things like that to get a particular effect. I'll come clean here, Shella. Don't actually consider myself a card-carrying expert on the method. I just know from time to time, for hackish reasons, if you include it, you can get charts to look good in the right way.
Yeah, no, this was a good hack tip. I kind of wish I knew it before.
yeah, that's all. Yeah, although I'd be saying, I don't know if I could give you some super, super clear explanation in terms of like the source code and how it works, things like that. So you just have to take my word for it.
No, that's good. Thank you.
You're quite welcome, Shella. All right, other questions?
So when we did mod.changepoints, those are the change points that are detected in the raw data. Right?
Yes, those were found automatically for you.
Right. Okay. And the change points are essentially like wherever the peak or wherever there's an inflection point in your graph.
Yeah, essentially wherever there's an inflection point inside some sort of discrete break in the trend that occurred.
Right.
Yeah, and so remember when we use change point prior scale, we can sort of change from 0 to 1. Essentially, what you're specifying is how abruptly does profit change its own inferred pattern from each of the individual change points.
Right.
So the idea is, if you set the change point prior scale to 0, you would effectively just be sort of fitting one smooth line to the entire time series.
Yeah.
Right. Yeah, and then the larger and larger it gets, then the more radically it's going to change from each of the individual points. So essentially, how much does it react to small local changes within a particular time pattern?
This makes sense.
Yeah. So that's basically, right? So if we were to set this thing to 0, like this is the line right over here, which sort of tells you, how it fit. If you were to change the value of the change point prior scale, right, you would see these changes right, within the pattern either be, more smooth or more abrupt, depending on what the value of the parameter was. And it's actually the most important attribute for how profit actually fits itself around its data. And just kind of gets back to the bias variance type of thing, if you're overfitting, underfitting, that kind of stuff.
Yeah.
Okay, beautiful. And then the default assumptions within profit are fairly conservative. So if you don't do anything, it is built more towards underfitting than overfitting. But in our case, that's maybe not the best example simply because we don't have much to work with in the first place. So there's not a whole lot of pattern to get. So, okay. But those are change points. Other questions that we have? By the way, it says we have 6 people in this room, but I only see the 4 of you. Is there anyone else here? Oh, no, apparently my screen counts as someone too. Okay, all right, okay. Okay, all right. Everyone ready?
Yep.
Beautiful, yep. All right. Okay, all right, so change points, right? Go ahead. Yeah, was there a question? Okay, all right, yeah. So change points are detected automatically by profit, which is often fine. All right, there's actually useful, right? Sort of algorithmically detecting when there are breaks within your time series, right? It would actually be cumbersome and probably ineffective to try and do that yourself. However, though, if you know there are specific breaks in the trend, or if very, very important events happened on particular days, right? And they sort of represented discontinuities in when things happened, all right? You have a few additional choices you can do here. So when you initialize profit, you can specify manually what the change points are. There is a small drawback to this. Let's take a look at this screen. Right, so you initialize it, you can say change points and say, we want to make sure something was noted on this particular day right over here. All right. The only issue though here is if you specify the change points manually, profits will not use these in addition to what it found before. This is going to be an exclusive replacement. Okay, so just to kind of summarize what we're looking at right over here, right? We initialize profit, we specify, some particular change point we fit, and then when we're done, it's not like we have these 25 values plus the one that we added. Okay, it is only this one right over here. Okay, which lots of times is not very useful either, because very, very often, right, if some particular event happened, it's not like you want to overwrite all of the pattern finding data within profit. You just sort of want to add your one little thing, okay, to make it better account for what happened. So antidote to this, right, if you don't want to manually specify everything, is you just have to fit your model in 2 steps. All right. So here, initialize, fit. And then do we see what this line is doing right over here? You might want to break it apart into a few steps just to make sure you know what it is. All right, all it's just doing is just taking the default change points that profit finds and then just converting it into string format and putting it into a true list. So I'll give us a minute here. All right, are we okay?
Yep.
Okay, good, good, good. Yeah, actually, I'm going to demonstrate this here quickly. I can do this here. All right, so we do this. There's no underscore, so we have this. Okay. And so just the idea, right? If you do this, it just turns all these things into pure strings. And so this way, if we do this, right, it just takes all these found change points and just conveniently puts it into a nice list. And so the idea is when you're done, if you have your own particular event that you want to add, all right, so in our case, maybe, like COVID happened, right, in the last 90 days or things along those lines, Profit as a default, just so you know, stops trying to find change points, usually within the last 10 to 20% of your data set to avoid overfitting. So if you have something that's very, very recent, it might not necessarily automatically find the detection for you. So if you want to add it manually, right, it's usually a good idea just to get your change points like this, put them into a list, okay, and then just add whatever it is, one that you want to tack on to the end like this. All right, and so now your new list, if we go over here, I'll do this, show changes equal here, all right, and then we'll append this right over here, okay. And so that allows you to find, right, both the learned change points from profit, which tends to be useful, and then any that you might want to manually add. And then if you wanted to, you could just go ahead and then refit with the entire list.
Quick question. If I had a change point that was sort of somewhere in between, do I have to sort my list again to ascending order?
No, you shouldn't have to do that. No, okay. No, that wouldn't be necessary. Okay. It would just assign the date for you.
Cool.
Yeah. Although if you wanted to do it, it wouldn't actually be all that difficult, right? Because you could just do like that, and that would put into order for you like that. But you shouldn't have to do that, Rashad.
Thank you.
Fair enough question, though. Okay, anyone else? Okay, all right then. So that is one item, right? So some people, right? So what do we do about COVID or things like that? We had some radical event that happened fairly recently, and so we don't really know how to account for that, right? The combination of manually adding various types of change points and then cross-validating the appropriate value of the prior scale to make sure it reacted to it accordingly was sort of how you would take profit and then sort of fit your model around those particular events that you knew to be important. All right, and then something that's fairly similar we're going to take a look at, all right, are if you have special events or holidays, okay? And then the idea behind these, change points are designed around sort of observed changes within your actual data. Like you knew something drastic happened on this particular day, not because it was preordained or specified by someone in particular, it just sort of happened, right? In this case, where you have special events or holidays, this is if you know you have particular events where there was a change in behavior around people or processes around the data that you're observing itself, and you wanted a way to properly quantify its impact. Again, big thing with this might be if you're working in a store or some sort of retail firm and you have sales or things like that, right? So you want to quantify the impact of sales, both to make predictions, but also to kind of understand what was the value add from some particular event that happened, right? So something maybe like Cyber Monday or, or Black Friday and that kind of stuff, right? Or, if there were changes in company policies and things along those lines, a lot of times you might want to make specifications for particular days and when they happened. All right. So our data set that we have here, it is Peyton Manning and his Wikipedia page hits. All right. And so since we're discussing the NFL, right, he's a football player, things like that. He's on TV, every couple of weeks. Days when he shows up either, in the playoffs or things along those lines or on the Super Bowl or those sorts of things could potentially have special significance. Like if you were to look at the pattern, right, of his web page hits, he's been in the Super Bowl 3 different times. All right. So it wouldn't stretch the imagination to think that the Super Bowl dates that he appeared on were very, very special dates in his particular timeline. All right, so I think lots of companies have their own specific list of dates they need to work with that they might want to properly account for. If you're doing a regular model like linear regression or random forest or things like that, you'd have to create your own separate column and do some sort of binary encoding. Like, was this date, was not that date, or like, this particular date happened before or after this event, or some sort of column that maybe measured the days since a particular event happened and things like that to kind of capture some sort of impact. So it's not like you couldn't do it with other models, but Profit just tends to handle these things a bit more naturally. All right. And then the basic idea is actually fairly similar to Changepoints, except it's not going to explicitly look for a break in your data. It's just going to go ahead and then make a note that something in particular happened on this day, and then add the results back into your model. So let's take a look. All right, so the easiest possible version of this, all right, if you want to account for holidays, you can just preload them. Okay, and so Profit has holidays already specified for about, I think, 24 different countries. So I would say for about 70% of the world population, you could easily enough go ahead and account for this. These are just the standard holidays that the country officially recognizes. All right, so if we do this, add country holidays. Obviously, if you live somewhere else, you wouldn't have to specify the US. I'll make sure we're here. All good, everyone?
Yes.
Okay, great. Okay, so that's not too complicated, right? That's just a single function call. All right. What you can also do, though, is you can specify your own particular data frame. All right, so in this case, these are the dates, right, during our time series where Peyton Manning appeared in a playoff game. And so what we're doing here, right, we're creating a data frame from a dictionary, and then we're actually assembling it into something that looks like this. And so the holiday and the DS has to be pre-specified. Okay, in the sense that it has to have holiday right over here as one column, and then it has to have DS over here as the other column like this. Okay, and so in this case, we're saying this is an instance of the playoffs, and this is the date that it happened right over here. And then you can specify this when you go ahead and then build everything. I'm going to paste this in the Slack channel if we just want to quickly grab this and then move with it. I don't know if it's absolutely essential that we know when Peyton Manning showed up in the playoffs. It doesn't strike me as being mission critical for anything you're likely to use this for. So if you want, I won't think badly of you if you just want to go ahead and just take that.
So like you were saying before, how the column names have to be D, S, and Y. Is that the same with like this with holiday?
It has to be pre-specified that way.
Gotcha. Okay.
Yeah. And then outside of that, Shella, actually in the lab, you're going to see additional ways to modify the effects. It's actually pretty flexible what you can do. You can basically define a holiday as being whatever you want. And just as long as you put it in a data frame like that, and then Profit will just go ahead and fit it in.
Cool.
And when we say add country holidays, actually all it's doing, Shella, it's creating a data frame that looks exactly like this. Except the holiday is Martin Luther King Day, and then it says Christmas, and then you have the corresponding date like that right over here. So it's just a convenience function for what we're doing right over here explicitly.
Got it.
Yeah. In fact, one of the more interesting parts of the lab that we're going to do is we're going to measure, right, the impact, if they existed, that the protests may have had on COVID-19 cases. And remember, Memorial Day was when people were kind of beginning to sort of like come out, and things like that and all that kind of stuff. We're actually going to measure lag effects to see, maybe 3, 7, or 14 days out, what was the additive impact of those particular holidays on total COVID-19 infections. But that's going to be in the lab. But yeah, so you can basically specify any particular day that you want as sort of being special or significant, and then add it in like this. Any other questions so far? Okay. In this case, we'll just say silence is good. So, all right, it means like we're just fine, Jonathan. And then we're going to do something similar here for Super Bowls. All right, so holiday, DS. So we have playoffs and then Super Bowls. I'm also just going to go ahead and paste this in if you just want to copy that. Okay, and so we have two separate data frames, one called holiday, one called DS. And then all we're going to do here is just concatenate them. All right, so what this means, I'm going to go ahead and get these things from Slack. All right, and then let me post them in here just so I can get them. Do we remember what concat does?
Does it stack them?
Yeah, it just stacks them horizontally. So pretty much here, we'll do this. You guys can see my notebook, right?
Yes.
Yeah,
Yes.
all right. So we have playoff right over here, right? So we're essentially saying playoffs are their own specific type of holiday, okay? And it occurred on these particular dates. And then we're saying a Super Bowl is also its own particular sort of holiday, right? So again, thinking like if you work for some sort of commercial store, right, you might have certain types of sales and then seasonal events and things like that that happened, okay? And you could specify them in a similar way. So if you have like a BOGO sale or something along those lines, you want to measure how this could impact whether or not something was about to happen in the future. Yeah, and so PD concat, just to make sure we're clear here. Yeah, all it does, notice here, these things have the same columns, and then their layout is basically exactly the same, right? So all we really have to do right? And now we have both of these things stacked. Okay. And so essentially, if you want to define your own custom holidays, it works the same way. And you just have your final data frame, okay, just to have these two columns. And then this one is the date. And then this one is the name of the holiday that you want to specify. And really, the meaning of a holiday in this case is pretty generic. Okay, it doesn't have to mean something that's religiously observed or things along those lines. It's just some sort of particular date that you might want to make note of. Okay. So do we have our master data set like this that's saved? So we can use it? Okay, beautiful. I'm just going to use Shella's affirmations as sort of like a cover for the entire class, and I'm just going to keep moving. All right, so we have this thing, right, in all of its glory. All right, and so now, right, so same thing. When you initialize it, there's an argument here called holidays. Okay, and you just specify it right over here. And then same thing, if you wanted to add holidays like this, you could. Just so you know, I know I mentioned this before, but add country holidays, and we say country name, US. Literally, all this function is doing is creating a data frame exactly like this and just preloading it with the dates of the American holidays. So you could just as easily get around this just by making a data frame like this yourself. So this thing right over here and then this thing right over here are just almost syntactic sugar for practically the same thing. Okay. So same thing, right? You could refit, you could validate your model, you could score it, all this kind of stuff, right? And sort of see if it helped or not. Usually adding special demarcations for important days tends to be fairly useful. All right, and so same thing. Let's go ahead, save our predictions. All right, and what's useful here, let's take a look at some of the detail. All right, so once you specify the holidays, okay, I'll make sure, I'll let us get to this. All right. Let me know when you're here.
Okay.
Okay, okay. Is everyone else okay? I've been sort of just indirectly talking to Shell for the last 20 minutes. So just make sure she's not speaking over the rest of the class. but no one's saying anything. All right, I just want to make sure everyone has like the stuff sitting inside their own computer screen so they can see it. All right. Okay, so this literally then, day by day, is the additive effect, right, of these particular holidays right over here. You can see most of the time the effect is 0. All right, and then if you wanted to, this is just a data frame, right? So what I'm calling predictions here is just a data frame. All right, so if one wanted to find out, suppose when the Super Bowl had an impact, so like when Peyton Manning is in the Super Bowl, right, what is the additive effect it has on his web page hits, okay, we could see these values right over here. Okay, and we can see it's actually, you know, this basically finds a single effect for every single unique instance of the holiday itself. Okay, so in this case, when Peyton Manning shows up in the Super Bowl, right, we basically, according to our model, find this much added on to the final number of millions of pages that he gets on any particular day. Okay, again, the lab is going to go over how to specify lags. So if you think the effect of a holiday or a sale, or in our case, like people showing up, you know, on Memorial Day weekend and going out on picnics, how might it sort of carry out over 3, 7, or 14 days? Okay, so the lab's going to get you over that. But for this case, what it literally does is it just looks at these particular days to figure out what the associated change is. All right, and if we want to look at this graphically, okay, once you go ahead and then pull the plot components, you'll see the specified additions for all of the holidays listed in your model itself. All right, so if you wanted to look at this visually, you could do so. There's also a way to specify a holiday individually if you were inclined. I don't have the specific function. I think it's called something like plot holiday component. It's fairly declarative. But that would allow you to pretty much take your predictions and just look at a particular holiday if you wanted to visualize, you know, how they cause some target variable to move up or down. Okay. All right, and I think that is actually everyone going to take us to the lab. Okay, where we're going to rehearse. Some of these things that we're going to do are going to tie in to what we did previous lab, where you're looking at your cross-validated results and then pulling in the MAPE and things along those lines. But the idea is you're going to go ahead and connect to COVID data, and then you know, kind of start with the standard baseline that we had from the previous workshop, where you have the Changepoint prior scale of 0.25. And then what you're going to do is you're going to take a look at different change points and then add in effects of holidays. You're also going to test the effects of different lags. Because the idea here, in our case, right, if you're looking at COVID data, if a bunch of people go out and have barbecues and picnics on Memorial Day, you might not observe the effects immediately. It might take, you know, 3, 7, or 15 days to kind of observe bumps in the numbers, because people typically don't get sick until about 3 to 5 days after they get infected. Okay, so it'll kind of walk you through how to go ahead and capture lags as well. All right, questions?
One random question.
Sure.
So in the set above, we often had 2 rows for the same date under holidays. That shouldn't have any impact, right? So for example, if you look at like all the Super Bowl dates are also mentioned as playoff dates.
Yes. So essentially here, if they're repeating, it will actually, essentially what it'll do then is it'll show the Super Bowl effect in addition to the playoff effect.
Okay.
Which is actually important here. Let's take a look here. So let me do this. That's actually a perceptive question, Rashad. Right, because everyone see that? If we look at that, in this case, right, Super Bowls, in this case, right, so a Super Bowl is also a playoff game. So it's like 2010, February 7th, right over here. Okay, all right. So the idea here, I'll go ahead and fit this. Rishab, you always were one of the more astute students. You know, your homework assignments always demonstrated as such. So I'm not surprised you would ask that and catch it.
Oh, thank you.
Yeah, no problem. All right, and then let's do this. All right, remember from last class, we found this one gave us the best results. So I'll just go ahead and do this. All right, so we'll fit. We'll let it go ahead, do its thing. Do. All right, we'll let it go here. Okay. All right, let's do this. So prids. So we do this right over here. Okay, all right, so take a look at prids. All right, I forget, let's take a look what the columns are. I forget what they're called. All right, so Y hat, additive term, Super Bowl. Okay, all right, let's do this. Playoff, Super Bowl. All right, and then let's build a query here. So let's do this. If what I'm doing here is not clear, feel free to ask. So basically, right, when these values are not 0. By the way, since we're only specifying it on this particular day, it's only going to look for an effect on this day, just so you know. So it's not as a default going to sort of spread out the Super Bowl effect over, 1 week or 2 weeks or a month or things like that. You'd have to specify that manually. So let's go ahead. And again, this is just kind of basic pandas filtering stuff. So let's do this. Okay, and so query grids.loc. And then we need to do here, period, like this. Okay, all right. So the idea here, right, where both of these values are not 0, let's do. All right. So these are basically the Super Bowl dates right over here, Rashad. Right, and so the effect of the Super Bowl is actually in addition to the effect of the playoff right over here. So the total effect of him being on TV on these specialized games would be these two added together.
That makes sense.
Okay. Yeah, so essentially this would be the additive effect of the Super Bowl independent of everything else. Because if you're in the Super Bowl, you are already in the playoffs, right, as a consequence. So it's the additional benefit of just merely being a playoff game itself.
That makes sense.
Mm-hmm. Okay, anyone else? I just realized my screen is kind of black. I should probably turn on the light. All right, but in any event, okay. All right, if we're okay, we're gonna go ahead and break into lab. If that's all right. No one is putting up any sort of, any sort of resistance. We'll also build in a 15-minute break. Okay, so I'll assume if you want to get up and stretch, things like that, 7:30. And then we'll give it about a half hour for the lab or so, if that's all right with everyone.
Yep.
Yep.
All right, and so we'll meet back here around 8 o'clock. We'll talk about all that's fit to print, and then just kind of wrap up with some stuff, and that'll be it. And it's going to be such a good time. So again, I'm going to go off screen here. I'm also going to go ahead and stop recording. So if you want to show your face and things like that, you're more than welcome to. So let me go ahead. In fact, I'll do that now. All righty, everyone. All right, so welcome back. All right, so we'll go over the solutions manual. All right, but before we do that, any general questions people had? And there is silence. Okay. I will tentatively take that to mean a good sign, meaning like you're able to get through it and you felt like you understood the answers versus total confusion. But if we're okay, is it okay if we just work through the solutions and take a look at things?
Yeah.
Okay. All right. Make sure we have stuff handled, and then we'll just kind of wrap it up and call it a night. All right. So let's take a look. I'll go ahead and open this up. Books, labs, slides. Okay. Some of these things, right, were a little bit of just kind of a rehearsal from what we did previously. Can people see my screen? Am I sharing? I forgot.
No.
No? Okay. All right. All right. Sorry, everyone. All right. So I'll go ahead and start sharing. Beautiful. Okay. Now, can you see it? I think you will here in a minute.
Yeah.
Yes.
Okay. All right. Good. Okay. All right. So let's just work through this a little bit, right? Kind of take a look at things, make sure we're good with the details. Okay. So we are just reading in our data frame, which is fairly ho-hum. Keep in mind, if you reread this every single time, it'll be a little bit different because it's updates every single day. So this would have about 13 more data points than when we last worked on this. All right. And so same thing, like Shella noted previously, so profit is just pre-encoded to look for certain column labels to work certain ways. So in the same way, right, the holidays data frame has to say holiday and DS. All right. Your primary data set that you're going to fit your model on has to say DS and Y. Okay. So this right over here is just doing a little bit of housekeeping and then sorting everything by date. So let's do this. All right. And again, this is fairly constant DF. All right. And so there's our data set. Okay. And this, right, is just a little bit of rehearsal from what we did in the previous class. Okay. So in this case, right, kind of the results that we found from previous class, right? So changing this value to 0.25 gave us the best CV results. Then we fit. Alrighty, and then we use this thing. This is sort of fairly similar to the cross-val score function we used in that, right? Where you specify how many rounds you want to do and things like that. But since it's a time series data set, right, some of the mechanics are a little bit differently. Let's just kind of make sure, are we okay with these parameters? So to say initial 100 days, period 20, and then horizon 3?
Yeah.
Just in terms of what they actually represent? Okay. Just to make sure we're good here, okay? The idea is you want some sort of a minimum initial fitting period just to make sure your model is minimally reliable in some particular way. If we fit on the first 20 data points and then predict it on the next 3 or things along those lines, that's so little. It's just not really going to be all that reliable. So we're saying only start the scoring after the first 4 months, right? And then pretty much what we're going to do is we're going to score, we're going to fit 120 days, right? Predict the next 3, score. Then because the period is 20 days, we're going to fit 140, right? Score days 141 through 143, and then fit 160, and then score 161 through 163, and then so on and so forth. Okay. So we run through this. We'll give it a minute here. Okay, we'll get the random warning. So this thing, yearly seasonality and daily seasonality, basically this means we don't have more than a year's worth of data. So there's no yearly seasonality to deduce. And then likewise, our time series is day by day. So there's nothing really to measure that's going to be hour by hour. That's what those error messages, not error message, but the warning messages mean. Okay. All right, so over here, right, we get CV results. All right, and so same thing. Let's just take a look here just to make sure we're okay with everything. All right, so pretty much we fit up to June 5th. Okay. And then we scored on June 6th, June 7th, and June 8th. Okay, in the sense that this is our prediction right over here. Rather, this is our prediction. This was the actual value, right? Prediction, actual value, prediction, actual value. And then because the cutoff date, right, the period is 20 days, we fit for 20 more days right over here up to the 25th, and then scored 26th, 27th, 28th. All right. And so we have this right over here. All right. And then we just have this throughout the rest of the time series. All right. And then if you wanted to, you could calculate performance metrics directly if you were inclined. But right, so performance metrics is just a convenience function. And so when we're done with this, let's take a look. Right, essentially all it does here Okay, it just tells us on each of the individual days various types of error terms. Okay, these are all basically different variations of the same thing, right? Some measure of what the actual answer was and then what the error was right over here. Mean average percentage error just tells us, right, on average, how much were we off by, okay? And then the idea, so all we're doing here is we're just taking the average of this column to get the average 3-day accuracy. That comes out to 0.165 right over here, which actually is a bit different from what the solutions manual is, just because there's daily fluctuation. All right, but we have this, and so that, right, is first corresponding round right over here. Okay, and this is designed basically just to be our baseline, right? So kind of without really changing anything except the prior scale, which we learned previously, what is sort of our basic result we're going to go ahead and start off with. All right, and then doing this, we're going to go ahead and then just test, looking to see if we can make some changes to change points, add in some holidays, and measure their effects in various ways. All right, so any questions, anyone, before we head on to the next step?
I just have a odd question. So like for me, we see that it's decreasing as the horizon increases. Is that the trend we generally see, or is it just a quirk of this data?
It is just for this one particular one. There's no reason that would actually necessarily generalize from one particular problem to another.
Okay.
That's very domain specific.
So does this almost mean that it's easier or it's better if I'm making a prediction for this particular data set that's 3 days out rather than 1 day out?
It really just means not so much that you make, I'm sorry, just to make sure you're looking at this one right over here and the fact that the error term is actually going down after 3 days.
Right.
Versus after 1. Yeah, correct. Was there a particular question you had, Rishab?
No, it was just, I don't think I had a question per se.
Okay. No, in this case, this honestly is usually a little bit unusual. Usually the shorter the horizon is, the more accurate you get. And so these numbers tend to get bigger over time and not smaller. But in this case, it's just an idiosyncrasy of what we're seeing. Maybe just due to the fact that, COVID data is choppy and irregular. And so it's actually a little bit easier to have more of a general trend that extends further out than looking at something that's immediately right in front of us. All right. Yeah, sure. No problem. Generally speaking, you would expect to see lower error terms the closer you are, and then bigger error terms the farther out. My guess is this basic pattern wouldn't sort of hold itself indefinitely. And if we were to look at a horizon of 5 days or 10 days or 15 days, it would gradually get bigger. I would actually be very surprised that didn't happen. But for this particular instance, it's what we have.
Oh, thanks.
Okay. No problem. Okay. Alrighty, so let's take a look. All right. So first thing, right, looking at change points within our data. If you look at the Wikipedia for the George Floyd protests, okay, it notes them as happening on May 26, 2020, all right, which is where the date came from. And so I don't actually know if this was coincident or not, all right, but okay, it just so turned out, back at least the last time I ran this. Okay, yeah, May 26th is in fact noted as a change point within the data itself. Okay, so in this case, there would be no need to necessarily specify it explicitly. You could actually toy with sort of adding it as a holiday to see if some sort of lag effect, actually had some sort of noticeable impact or things along those lines. But in terms of actually explicitly having to note that as some sort of inflection point, it is already there. Okay, so in this case, we could essentially just kind of go ahead and pass. But if we wanted to go ahead and add it in later on, we could. If it wasn't there, we felt like that was significant. Or for a lot of people, right, if you're just have some sort of general forecasting problem and you have years of data and COVID happened like fairly recently, right, you could probably add the onset of COVID as a particular change point if you wanted. But in our case, this is fairly simple. We just kind of had to it basically already found, it actually remains this really indeterminate if that data is there because of the protests or if it's just due to a coincidence. But in any event, it's there right there. And then next step, right, is just seeing if accounting for some holidays makes anything get better or worse. And so we do this, right? We'll initialize prior scale 0.25, add in holidays. And so same thing, we will walk through this again. Okay, we can see here probably more than anything, the effect seems to be not so much, okay? I think that when I ran this a couple of days ago, it ended up being a very, very modest decrease, but the change is quite small. And we have this here, although it is very, very, very modest, right? So just looking at holidays all by themselves pretty much changes the overall error metrics by a fraction of a percent. So first blush, right, if we just look at changes that happened on particular days with holidays, it didn't really seem to add any sort of effect to our, if it was very, very modest. You might be able to look more deeply if it was 1 day, 2 day, or 3 days out, if those got better. All right. But all by itself, it seemed to do actually very, very little. And then if you wanted to plot this, right, we could see the same corresponding results right over here. My guess, so this corresponds to President's Day. This is Memorial Day. And then this is the 4th of July right over here. Generally speaking, this is probably when COVID cases were just getting, we're getting large in general. All right, so there was already an upward swing. You know, perhaps, you know, people were probably not very good or being very, very conscientious about doing protective behavior. So perhaps this spike that we see right over here actually is due to the holidays themselves because lots of people are off. And this was before March, right? So people, for the most part, were not really heeding any warnings or things along those lines. So there actually is probably a decent chance this may have been something of a catalytic event in terms of additive effect, right, of COVID cases, because this is when we had those steep accelerations. If you look at various types of dashboards, things along those lines. All right, but in any event, right, even if we do account for these things, the overall results seem to change very, very little. And then the idea then is checking to see if there are any perhaps impacts of different lags, all right, which conceivably could be true for COVID, right? Because the idea is we're measuring COVID cases, and then COVID cases typically won't show up maybe 3, 5, 7, or 10 days afterwards. Okay, so if there's a prolonged effect from some event that happened at a particular day, you can also specify this. All right. And then if you all remember, I mentioned before, when we do something like this right over here, add country holidays, country name is equal to US, really all we're doing is just making a data frame that looks like this and just specifying all the individual US holidays. All right, so the basic idea here, if we want to capture lag effects for different holidays, which in this case seems appropriate because we know like for what we're measuring, there would be some sort of time delay between when the event occurred and when we actually notice a change in COVID cases. So pretty much in this case, what you have to do is you have to make the holidays data frame automatically. So we'll go down over here. Okay, so profit, make holidays, right? A function over here called make holidays df, all right? All right, and so essentially when you're done, right? So when we say add country holiday, we're pretty much given a data frame like this. And here we just specified year 2020, right? And then these are the officially recognized US holidays and their corresponding dates. Again, if you wanted to, you could add any other custom holiday if you wanted to. So if you wanted to make a sort of something for Juneteenth, if you wanted to add the George Floyd protests as their own distinct holiday over here versus having May 26th at the Changepoint, you could do that as well. Okay, it doesn't really matter too much. All right, and now the idea then, right, upper window, lower window, if it's set to 3 or 0, you have to specify both of these for profit. In our case, intuitively, I wouldn't think any sort of lower window would actually have much of an effect. But in any event, if you want to sort of capture something that maybe happened before or after some sort of holiday occurs, then you have to specify both. It's not one or the other. So when we're done doing this, we'll get an error message, probably because I didn't run this one beforehand. All right, so here is holidays. Okay, so big thing here. So when we say holidays is equal to holidays, what we have here, okay, the data frame has these 4 columns, right? DS, holiday, and then the upper window, and then the lower window, which basically just tells you what kind of time frame it uses to account for the presence of these particular dates right over here. All right. So before we go through the next loop, right, to test what sort of lag value is most appropriate, let's just make sure everyone's following along. I'm under the impression you all finished the lab, right? So you're able to observe, the answer solutions manual, things along those lines. So I'm going to guess we're default okay, default following along.
Yep.
Okay. And Rashad says, yeah. And so it was that the class is okay. All right. So, all right. So here, holidays. Okay. All right. So we have this. And again, this is just setting a loop right over here. Maybe you wouldn't have had to have done this programmatically, right? But this is kind of the clever way to do it. So the idea then, right, if there is some sort of lag for holidays and we wanted to capture that, right, we're going to go over here. This should seem fairly familiar from some of the things we did in class, right? Looking at cross-validated results to kind of test for different types of model and parameter changes. So we're doing something similar over here. We're saying check, right, for values 3, 7, 14. We're going to loop through them right over here. We're going to take this data frame and set this column value, right, to whatever the value in this list is right over here. All right, we're going to initialize our model, right? We're going to use this version of the data set, this version of the prior scale right over here, okay? And then we're going to run this through CV, okay? Take a look at the CV results, and then finally get the average value of MAPE. And then we're just gonna go ahead and then log these at the very, very end. This takes a little bit of time to fit. Okay, so we'll just let it go ahead and then run. And again, the data updates itself on a daily basis, so it's possible our results might be a little bit different. Okay, they typically don't have dramatic effects. Looking through this here, I think it was 0.165 before, if I'm not mistaken. That's what the results came out to be in terms of, okay, 165. So 162, we have a modest increase. Okay, 161 right over here. Okay, here we're done. Okay, all right. And so it looks like over here, 7 days gave us the best results. Was this reproduced throughout the class? Bueller?
Yes.
Yeah. Okay,
I'm just curious, why the 7 days was the best results?
In some ways, why was it the best results? I don't actually have a super deterministic answer, but really kind of the benefit of doing it this way is that basically by accounting, right, for a lag window of 7 days, we're just able to capture the time-based effect of COVID results more accurately. So basically, the way we would interpret this, Edwin, and then everyone else, basically means in terms of accounting for the effect of a holiday. In this case, right, presumably the holiday, the lag window, basically means to sort of capture for the appropriate amount of time for the effects of the behavior changes on those holidays to manifest themselves, right? We're able to actually sort of just capture the dynamics of COVID themselves if we assume that there is some sort of 7-day window through which the holiday effects take place. So in a lot of ways, it's actually better to sort of think about the result of the model itself to answer the question than to sort of start, well, why would 7 days be best? But instead rather say, according to our model, 7 days is best because once we sort of account for that window, that's the one that gives us the best results.
Okay.
I mean, really the big point of modeling is that if you are doing taking the appropriate steps to sort of measure your results in an honest way, they give you the way to answer some of the more interesting questions that you might have. So in this case, we could say we best account for the effects of holiday behavior, right, when actually sort of using a window of 7 days long. It allows us to kind of best capture what happens when people actually sort of how they impact COVID.
Okay.
Yeah. So in this case, like if you were to sort of think about something like this, you could basically just say, according to our model, right, using a 7-day window allowed us to best capture the effects of, July 4th, Memorial Day on total COVID-19 cases. And so you kind of need 7 days to sort of observe the impact of a particular holidays on the final outcome that we're looking at.
Got it.
Are there any sort of rules of thumbs that we should use? Because I mean, the difference between a 3-day lag and a 7-day lag is really not that much. It's less than 1% in May. So like, should we just like look at the absolute differences in choosing this, or should we use certain rules of thumbs and say that like only if the difference is significant by some means should we account for the lag? Or
yeah, it's usually fine to take usually if there are only very modest differences between them, the smaller lag is probably going to be a little bit more reliable. Lots of times the lag effects for COVID are a bit unusual simply because, there are lags in infection times, things like that. I would actually say more often than not, if you're looking at specific holidays, and this is very often for things maybe like demand forecasting, for maybe if you have things like traffic congestion or number of tickets and stuff like that, you might have travel, before, during, or after the day. So more often than not, honestly, Rishabh, in terms of just basic rules of thumb, it's not too often that you might have to go beyond 2, 3, or 4 days. But this is something of a special circumstance because we know the sort of the tail effect of COVID-19 on the observed result is longer than usual.
yeah, that makes sense.
Generally speaking, this is a bit more difficult simply because the data set's fairly shallow and irregular. And so typically, if you actually had the chance to find truly yearly patterns, you could probably just go with the one that gave you the smallest value and feel fairly comfortable with it. Because profit actually does work best when you actually have a chance to determine yearly seasonality. So at this time next year, if we were to rerun the same results, we could probably just say whatever kind of gave us the best results, we could just kind of declare that fairly quickly. But if we're talking about irregular data that we have right now, which is fairly shallow, it probably wouldn't be a bad idea to err on the side of a smaller window than not. Okay, because for example, literally, I put the finishing touches on this about 3 days ago, and then 14 days gave me the best results. And so we can see now it actually shifted to 7. So it's probably not too uncommon that these numbers bounce around a little bit.
Right, that makes sense.
Okay, let's take a look. Okay, all right. So there is a modest effect when accounting for holidays, all not really that large, and it tends to improve slightly if you sort of accommodate for some sort of lag, which also makes sense because we know, right, if you get COVID, it doesn't show up immediately, but after 3 to 7 days is typically when you'd probably experience the effects. All right, so that actually agrees with my intuition to some extent. All right, and so let's go ahead and do this one. So we'll do 7. I'm going to go ahead and change this one. 0, 7, and then let's take a look. It was 7, right? All right, upper window. And so now we'll do this one. All right, and so same thing. We have our predictions right over here. And so what we're doing here, just so we know, okay, so most days, these are 0, because it's basically only looking at Memorial Day, at Independence Day, all right? And then taking a look at 7 days after it right over here. But the idea then is these are additive effects, so we should, if we add these together right over here, okay, this would essentially represent the additive effect of these two holidays right over here like this. Okay. Overall, they don't actually amount to very much because if you remember, our final result improved slightly, but not a dramatic amount. Okay. But if we were sort of answer, so how many cases, right, were added or subtracted from the total count due to behavior on these particular days, right? This is how we could go ahead and report a number associated with it. All right. And that took us to the end of our lab. Okay. Questions, anyone? All right, so can I bounce a few ideas off you all?
Yes.
Sure. All right,
Sure.
So one of the reasons why I like the idea of putting on these seminars is it kind of gives us a chance to take a look at some topics and go into them more depth. And so I'm thinking what we'll do is we will have 3 to 4 more of these types of classes on profit in particular, and we'll keep working through some additional problems. And then we'll probably have a class specifically for time-based cross-validation and some of the details of that. We'll look at hierarchical time series, which is when you have smaller subgroups. So if you're predicting sales off of individual regions, or maybe, attendance based off of individual branches or things like that and kind of aggregate them up versus just having a single time column. And then we'll wrap it up by doing more of a deep dive into how profit itself works, which will kind of give us a peek into Bayesian modeling and sort of how probabilistic programming works at more of like the grass level. So what we'll do is we'll actually take a look and then we'll recreate some of these predictions by hand. That's the idea. And so it'll spread out about 3 or 4 more classes.
That sounds awesome.
Yeah, I think it's fun, right? So we can actually spend, like a couple weeks or a couple months on a particular topic and become more comfortable with it.
Will that include something like if we want to forecast, let's say, per product?
Yes, exactly. So the idea is if you have different individual products that you want to build a forecast, and then also if you want to build both the individual products and then also an aggregates forecast from all the individual products themselves.
Nice.
Right, because a lot of times forecasting is you kind of have taxonomies and stuff, right? Yeah, you have individual products that belong to different categories, which belong to different stores and things like that. It's pretty common. So it's not just always you just have like a date column and then some sort of target variable, but you have the different components of it. And so we'll probably do that either next workshop or workshop after that. And I'm also thinking we might have one. There's not going to be any new material, but we might take a larger data set that's a bit more complicated and then just work on it for about 3 hours.
Nice.
Yeah, and then it'll culminate in kind of the deep dive into profit, which is actually, it uses something called STAN, which is sort of this Bayesian programming library. And so we'll basically kind of work with STAN directly and then like assign things to priors and posterior probabilities and like do some sampling and things like that. To me, it sounds like a good time, but I'll just run it through you all to see what you think.
And for me, it's brilliant because I can use these library directly at work. So we do a lot of time series modeling at work. And
yeah,